Now we will learn the concept of compound interest, and then we will go through the formula to calculate compound interest, and we will solve the examples based on compound interest. When interest is added to the principal at end of each period and the total so obtained is treated as principal for the next period, then the interest so obtained is called as compound interest. Here, my dear students, one thing you must note is that in case of simple interest, whatever may be the term, the interest is always charged on original principal. But in case of compound interest, interest is added at the end of each period and the new principal is generated or formed by adding interest at the end of each period, and therefore this new amount which is obtained is treated as an principal to calculate the interest. This is called as compound interest. You can note in case of compound interest, the interest is added every year to the principal and the amount so obtained is used or treated as principal to calculate interest for the next period, and therefore it is called as compound interest. In compound interest, we have to pay greater interest to the lender. Now we will go through the formulas to calculate compound interest. The formula for compound interest is A is equal to P into bracket 1 plus R upon 100 raised to N. By using this formula, we can calculate amount, and you all know amount is equal to principal plus interest. Amount is equal to principal plus interest. So, in the calculation of compound interest, the first step is to find out amount. Amount is A, and that is equal to P into bracket 1 plus R upon 100 raised to N. Here we will understand each and every term. Here P represents principal, that is sum borrowed. R represents rate of interest per annum. N represents the period in years, that is term or time. And A represents amount at the end of N years. This is the first formula. The second formula is, after calculating amount, we can have compound interest. CI is nothing but compound interest. CI, that is compound interest, is equal to A minus P. When we substitute the formulas for A into the equation will become like this. So finally, we can say that compound interest is equal to P into bracket 1 plus R upon 100 raised to N minus 1. By using this formula, we will calculate the compound interest. Now, my dear students, we will solve examples based on compound interest. This is the first example. The example is on your screen. The golden rule we will use, we will read the example for at least 2 times. We will try to note down what has been given in the example, and we will find out what they have asked in the example. The example is like this. Find the compound interest on rupees 10,000 for 4 years at 5% per annum. In this example, they have asked us to find compound interest, that is CI. CI is compound interest on rupees 10,000. That means they have given us P. P is equal to 10,000. R is equal to rate of interest. They have given it 5% per annum. N, they have given us 4 years, and we have to calculate compound interest. Now, first of all, we will try to calculate A, that is amount, by using formula A is equal to P into bracket 1 plus R upon 100 raised to N, and then we will calculate the compound interest. The amount at the end of 4 years is given by the formula A is equal to P into bracket 1 plus R upon 100 raised to N. We will put in the values of variables which we know, that is P, R and N, and we will find out what is the amount. Amount is equal to rupees 12,155. Now, my dear students, we have P 10,000, we have amount 12,155. We all know that A, that is amount, is equal to P plus I. If we make interchange of the terms, we can easily find out compound interest. How? Compound interest is equal to A minus P. That means 12,155 minus 10,000, and it becomes, or it is 2,155. So you can say that the compound interest is rupees 2,155 for rupees 10,000 for 4 years at 5% per annum. This is example number 1 based on compound interest. Now, I hope you have understood how to calculate compound interest when they give sum, that is N and R. We will move towards the example number 2. Find compound interest on rupees 5,000 at 4% per annum for 5 years. Again, if you read this example, you will note that they have given us some information in the example, and again they have asked us to find out compound interest. So, in this example, we have to find out CI. They have given us the sum. Sum is equal to P, and that is equal to 5,000. They have given us R. R is equal to 4%, that is 4, and they have also given us N. N is equal to 5 years. So, here in this example, P is equal to 5,000, R is equal to 4, N is equal to 5 years. Once again, what we will do, we will find out amount, and after finding the amount by using the formula A is equal to P into bracket 1 plus R upon 100 raised to N, we will try to calculate compound interest after finding out the amount. How we are going to find out compound interest after finding out amount? Because we all know amount is equal to P plus I. Therefore, we can say that CI, that is I, compound interest, is equal to amount minus P, that is A minus P. So, first of all, we will find out amount. A is equal to P into bracket 1 plus R upon 100 raised to N. Now, we will put in the variables values which are known to us. A is equal to 5,000 into bracket 1 plus 4 upon 100 raised to 5. If we solve this equation, we get as amount is equal to rupees 6,083.264. This is amount. If we know the amount, it is now very easy to calculate compound interest. Compound interest can be calculated as CI is equal to A minus P. Here, A is 6,083.264 minus the P is 5,000. So CI is equal to 6083.264 minus 5000 and it is equal to rupees 1083.264, that is 1083.264 rupees. So we can say that compound interest is equal to rupees 1083.264. So if the sum is borrowed, that is 5000 at 4% per annum for 5 years, one has to pay compound interest of rupees 1083.264. So my dear students, till the time we have solved 2 examples based on compound interest. I hope you all are getting whatever I am saying. So now we will move towards the next example based on compound interest. See, if you go through the example, it's a very tricky example. The difference between the simple and compound interest on a certain sum of money for 4 years at 6% per annum is rupees 168.75. What is the sum? Question mark. Now, in order to solve this kind of an example, we have to again use our golden rule. What is that golden rule? We will try to first of all understand the example and we will read it for at least 2 times and we'll try to understand what they have given in the example and what they have asked to find out in the example. The difference between the simple interest and the compound interest on a certain sum of money for 4 years at 6% per annum is 168.75. That means in this example, they have not given us sum. They have given us there is a difference between simple and compound interest is 168.75, means the difference between simple interest and compound interest is 168.75 is if the sum is same. If sum is same, rate of interest is same, number of years is same, the difference between simple and compound interest is 168.75. We can solve this example like our school days. If you remember, when we are in school, our teacher used to ask us, we will assume either sum is equal to x or we will assume sum is equal to rupees 100, and we are going to use the same trick which has been given to us by our school teacher. To solve this example, first of all, we will assume that let the sum is equal to rupees 100. By assuming sum is equal to 100, we will solve this example and then convert those answers to find out actual sum which is asked in this example. So, first of all, we will solve this prototype example by using or by assuming sum is equal to 100 rupees. Though we have to calculate sum in the example, we are assuming first of all the sum is 100 and we will calculate simple interest, compound interest and difference, and with that reference we are going to find out the actual sum which has been asked in this example. So first of all, we will assume sum is equal to 100 and then we will try to calculate simple interest and compound interest. If sum is 100 and we have to calculate simple interest, we will use formula I is equal to PRN upon 100, and in that formula we will put in P as 100, R as 6 and N as 4, and in this way we will calculate the simple interest. This is like this. Here comes simple interest is equal to PRN upon 100 and we will put in 100 into 6 into 4 divided by 100 and is equal to 24. That means if the sum is 100, period is 4 years and the rate of interest is 6%, the simple interest will be 24. Now we will assume the same, that is 100, and we will calculate compound interest. Now you all know how to calculate compound interest. In order to calculate compound interest, we have to first of all calculate amount. Then we will use formula. Compound interest is equal to amount minus P, and we have assumed P. So amount is equal to P into bracket 1 plus R upon 100 raised to N. We will put in P as 100, 1, 6 as R, and N as 4. So 100 into bracket 1 plus 6 upon 100 raised to 4. This will give us the amount, and that amount is equal to rupees 126.25. If suppose the sum is 100, N is 4, R is 6, amount is 126.25. Now what we will do, like our example, we are going to calculate the difference between simple interest and compound interest. Simple interest is rupees 24. But before moving on to calculate the difference between simple interest and compound interest, first of all, we will find out what is compound interest. So, my dear students, we have calculated amount is equal to 126.25. But, my dear students, this is an prototype. We are assuming that P is equal to 100, and by assuming P is equal to 100, we have calculated simple interest, and assuming P is equal to 100, now we have to calculate compound interest. Compound interest can be calculated by CI is equal to A minus P. Here we have found A is equal to 126.25 and P is equal to 100. That means compound interest on sum of rupees 100 for 4 years at 6% per annum is 126.25 minus 100, and it will come to rupees 26.25. So, by assuming sum is equal to 100, simple interest is 24 and compound interest is 26.25. Like example, in example, they have given us on a sum, simple interest and compound interest is having difference of rupees 168.75. Here, by assuming sum as 100, the difference between compound interest and simple interest is 26.25 minus 24, and it is equal to rupees 2.25. Now, this is the critical point in this example. In the example, original example, they have given us difference between simple interest and compound interest is rupees 168.75 and asked us to find sum. In a prototype, we have assumed that the sum is 100 and we have calculated simple interest and compound interest. And the difference between simple interest and compound interest as 2.25. Now, we are going to compare two situations. First situation, when sum is equal to 100, the difference between compound interest and simple interest is rupees 2.25. And the second situation is keeping all the other thing constant, that is N is equal to 4, R is equal to 6%. We have to find out sum when the difference is 168.75. So, in our school days, we used to compare and find out unknown variable in this fashion. we will put like this. The for difference of rupees 2.25, sum is 100. So, we will calculate for difference of 168.75. What will be the sum? This is the equation for difference of 168.75. What will be the sum? We will do cross multiplication. What is cross multiplication? That 168.75 into 100 and 2.25 into sum. And if we do cross multiplication, this will be like this. 100 into 168.75 divided by 2.25. This equation will give us the sum we are finding. Now, the sum by comparing this one equation with the other equation, sum is equal to rupees 7,500. This is our answer we are searching for. So, my dear students, the final answer, the sum is rupees 7,500. Once again, I will put it in other words. If the difference between simple interest and compound interest for a period of 4 years at 6% per annum is 168.75, then that sum is rupees 7,500. This is all about the examples based on compound interest. I hope you all have enjoyed this session of simple interest and compound interest.